infrastructure architect at Novartis Institute for the Biomedical Research in Cambridge. So he's going to tell us a little bit about coding in the real world and what he does, and just a little bit beyond Hour of Code. So I'll turn it over to you.
Cool. Excellent. Hi, everybody. Can you hear me? All right. Okay, let me see if I share something with you. Tell me that if you can see it okay. Hang on one sec.
Okay.
Right there. So do you see that okay? Okay. Yep. Do you see me, or do you just see that?
We just see that.
Okay, so I'll try to talk, and I can kind of see you a little bit. So, and if somebody has a question, we'll try to save some time at the end, and we'll answer questions.
Okay, sounds good.
Good. So, hi everybody. I'm, as Jessica said, I'm her uncle, or I'm sorry, as Mrs. Barrett said, I'm her uncle. And I work in a company that helps to discover medicines and drugs to cure disease. Now, you might think, but that's not coding, that's medicine. But coding helps you when you go to discover medicine. And I'm going to show you guys how, and I'm going to tell you some stories about how people who helped write code helped find cures for diseases. And then when I get done with that, we'll talk a little bit about places that you can go to log in and actually start to practice writing some code yourself. And you might know about some of them, but we'll talk about them. So what do I do? I'm something called an architect. And sometimes when you build a house, you have to get a person who's an architect. And what they do is they come in and they kind of design the house, and they kind of tell everybody how the house should be laid out, and where the windows should be and where the doors should be. Well, when it comes to code, I kind of do the same thing. I tell people how they should write the code and how they should do their searches on numbers, and how they should store their code on big servers, and how they should use networks to move data around. So that's the work that I do every day. Now, you guys might say, how does code help solve diseases and help people? So has anybody heard of things like genes in your body? Not genes like you wear in your pants, but genes like you're in your body.
Yeah.
So when you're born, you get a whole bunch of genes. Some of them comes from your mom and some of them comes from your dad, and they get mixed up and they turn into your who you are. It says whether you have dark hair or light hair, whether you have blue eyes or brown eyes. It's kind of like the blueprint for how your body gets built. Well, scientists discovered that they can read that blueprint. And they got a bunch of machines that can take your cells and they can read what your cells are, how your cells are designed. And the way that comes out is a whole bunch of letters. And actually, there are 3 billion letters in that the way that's designed inside your body. And 3 billion is a lot of letters, but it's also it makes a big challenge for doctors who are trying to use those letters, that code, to understand how your body works. And this is where computers come in. We can use computers to help doctors read through those codes of people's cells. We can read through their genome or their genomic data. And the more and the faster that we can help them read those codes, the more and the faster they can help find a cure for certain diseases. Does that make sense? I'll stop for a second, and I can see you guys okay, even though you can't see me. I'll keep the sharing up. Anybody have any questions at that point so far? Okay, I'll keep going. And if you have a question, just raise your hand, because I can see most of you pretty good. So the scientists discovered how to read these blueprints for the body, and some people, like, all you have to do is give them a small bit of skin or even spit. You can even just spit into a cup, and they can take your DNA out of the spit and understand how your whole body is put together. We take that data and we get it into computers, and once we get it into computers, people can look at it and study it, and they can help determine what genes might cause some disease. So far, so good. So this is a picture that kind of shows how scientists actually have to look at all these genes. Now remember, I told you there are 3 billion letters that they have to go through. And there's no way that they can look at them all at one time. 3 billion is like, that's more people pretty much than there are in the world. I think there's 4 billion people in the world, but there's 3 billion letters in your genome. And if a person was going to read it like a book, it would take forever. Instead, we have computers that can search it, and they can search it really fast. And we can train the computers, and we can, using code, we can train the computers to look for certain patterns in the genes. And those patterns will help us know what disease the people have. And if we know what the disease is, then we can cure it really quickly, and we can cure it really well. We don't have to guess. Like sometimes when you have a cold that you might, or a sore throat, you might go to the doctor, and the doctor says, well, I don't know, maybe the person might have strep throat, or maybe the person has the flu, or maybe the person has allergies. Well, having the genomic code helps the doctors zoom in on exactly what it is. And if you have a disease like cancer, which is a really bad disease, and we want to find out what causes your cancer really fast, we want to be able to look at your genome and find out which one of those pieces is broken. And then we know how to cure it. Once we figure out what part of it is broken, then doctors know how to cure it. Now, there are some great stories about how this works. And I'll tell you one story about this girl. And this is a great story. And I put her name is at the bottom. Her name is Emily Whitehead. And she has a blog, and it's on that email, on that address. It's at the bottom of the page. So this girl had a terrible kind of cancer that's called leukemia. And leukemia is, unfortunately, it's a kind of cancer that gets kids, it's a cancer that starts sometimes when you're a kid. And she had it, and she was sick. I saw a video interview with her, and she was so sick, and the doctors had tried every kind of medicine that they could on her, and none of it worked. And the doctors were at the point where they had to give up, and they told her mom and dad that they didn't think she would make it, and there was no more medicine that they could try on her. Now, don't worry, this is a happy story, because here she's still in the picture. So what the doctors did was they took a sample of her genome, and they looked at it, and they found a way to go in and change her genome just a little bit to help her body fight the cancer all by itself. And nobody had ever done this before. This was a new way of treating this disease. Nobody had ever done it before. This was the first girl, and she was so brave that she tried it because she didn't know if it was going to work, and the doctors didn't know if it was going to work. And they took some of her blood cells out, and they changed the genome, and they put it back in, and those blood cells got in, and they multiplied, and they went through her whole body, and those blood cells were like hunters. They hunted down the cancer, and they got rid of it. And the doctors were able to use the genome and train her body to get that cancer out. And now you see that picture. She says 5 years cancer-free. That means she has been healthy for 5 years, and it's completely gone out of her body. And now, because she was brave and allowed to work with the doctors, now they're using that on more kids and more kids. And they got approval, and they can use this on people all around the world. And so this is how the people who wrote the code to go in and decode that genome, those people helped contribute to the cure for this girl's cancer. So I'll take a small pause now, and that's talking about the data that is called genome. And I'll wait and say, I'll stop sharing so you can see me again. And I'll say, does anybody have any questions about that so far? And then we'll go talk about code and a little bit more how we use software and code. So far, so good? Excellent. All right, give me 1 second and I'll put that share back on. Okay, so what is code? Do any of you guys even have an idea of what code is? What do you think it is? Guy in the blue sweatshirt right in the front.
It's like code, like that. Like when you make a video game, you have to code it for it to work. Like if you just make the software, it doesn't, like on a phone you have to code the software so it can activate and actually work. Because if there's no software on a phone, it doesn't really work because the software builds the phone. So you have to have like the screen. You have to code the video game or the phone for it to actually work, because the game has to be able to move, but it's not really a game. It's just a screen that stays there. So in a phone, like the software helps the screens, like you can touch the apps or move the sides of like the screen, and like it helps you, like you can take pictures with it, and it sends messages to other parts of the phone to so it activates that part of the app or part of the phone. And so when you download a new app, like when you first activate it, sometimes it takes a little longer than when you go on an app that you've had for like a couple months, because it's a new app for your iPad or iPhone. So it's like new so it has to load a little for it to activate on not activate on your phone, but load on your phone. And so it like helps like the phone actually work, or the video game actually work.
You are absolutely right. Woo. Do you want a job? So he's absolutely right that machines called computers or machines called phones are absolutely no good until we write the instructions to tell them what to do. And there's a lot of people that write those instructions, and sometimes the instructions are good for doing games, like you said, and sometimes the instructions work on a telephone or a cell phone, or sometimes the instructions work on a computer, or sometimes the instructions work on a network or other things. But all of those instructions have to work together. So that's exactly what code is. It's basically just a written language. But the interesting thing is there are a lot of languages in computer code. Just like in the world, we have some people speak English, and some people speak Spanish, and some people speak German and French or Chinese or any other language. Just like that, in the world of computers, there's a lot of different languages, and sometimes they use certain languages to do certain jobs. And so you guys can see on the picture in the front, on the picture on the presentation, these are some languages that people use in computer world, in building up different applications and building up big complex systems. So for instance, when we talked about that girl who was able to get cured because they decoded her genome and looked and found the place that it was broken, scientists probably used a piece of code written in Python, and they may have used a piece of code that was written in C++, and maybe they had a database and they accessed it using a language called SQL or SQL. So scientists and software developers use all different kinds of languages. This is only some of them. But even when you get beyond writing instructions in code, you start to get to a whole other set of software, which is kind of called frameworks. And these are things that the code plugs into. And one of the reasons why I did this slide is because I just think the pictures are really cool. And I wanted to show you guys all the pictures that when somebody invents a new kind of software, one of the things they get to do is they get to name it, and then they get to pick a picture to go with it. And so, like, if you look at that picture, right in the middle, there's a picture of a cat, and that's for a piece of software called Tomcat. And somebody, like, just wanted to name it after their cat, and so they named it Tomcat. And there's another piece of software there on the right side that's called Zookeeper. And what that software does is it helps all the other software run, and it keeps it all running along the right way. And so that guy named it Zookeeper. And then there's another piece of software there called Hadoop. And this was a guy who wrote the software, and his daughter actually had a stuffed animal elephant that his name was Hadoop. And so he told his daughter he would name the software Hadoop. So there's a huge amount of, there's a huge number of these tools that you can use and plug together to help you do certain things in the world of software. But even there, it doesn't stop. There's even more, and I still haven't put all of them on the screen. That software then runs on top of other software, and you can see there's things called Jenkins, which is a piece of software that helps move things around, and there's Docker, which is a piece of software that helps take your application and move it from one place to another. And somebody invented a piece of software called Logstash. And which one do you think is Logstash? The log with the mustache, exactly right. And then there's things like Amazon Web Services, and there's a tool called Splunk, which helps you explore deep into data. And all of these tools have to work together. But the one thing that ties them all together is that somebody writes the code. Somebody writes the language that links them all together and shares data between them. And maybe someday you will grow up and you will get to write your own set of infrastructure, your own set of tools, and you'll get to give it a name. And you'll invent a really good name. Maybe it'll be something based on a toy that your kids have, or maybe it would just be a name that you made up out of thin air. But these are all different pieces of software, and people who write code have to understand how to talk to each one of them. And that's why it gets to be a pretty complicated world in tying all this code together. And that's the reason why there's people like me who are architects who help bring coders together and help them bring these tools together and get them onto servers so that they can run. So now, how can you guys start to touch some code and actually do it yourself? I put together a list of websites that you can go to, and your parents can help you get access to these. Your teachers can help you get access to these. Some of them are free, like the first one, which is called code.org, and that's free, and it's got different sections that are good for little kids or medium-sized kids or older kids or even adults, and it helps you learn how to write the instructions to do things like make video games, or how to write the instructions to do things like load pictures on the internet or anything like that. So code.org is one that's free, and Scratch is another one that's free. And both of those, I think both of those come from the university called MIT. Then there's two more that cost money, but they have a free section for people who want to do an hour of code project. One's called Tinker and one's called VidCode. And both of those have a free section, so you can use them without having to pay any money. And then the last one is Hopscotch, and that's a download for your you can download it on your iPad or on your iPhone. And it's a way that you can start to test and play with code and write things that you can see and have them come out the other way. So that's everything I wanted to say about the work that we do here, and how code helps us. Get all the data together and analyze it to help cure diseases for people that have that are looking for cures. But one thing I wanted to say at the end is that writing code is good and it's important, but there's a lot of experiences that help you be a good troubleshooter. Because when you write code, you have to be a good troubleshooter. Code's always going to have problems, and you're going to write something and it's not going to work the way you want it to, and you're going to have to go try something different and try something different. And one of the things I wanted to say is make sure that you get a lot of experience besides just writing code. Even things like fixing bicycles can help you when you try to write code, because when you fix a bike, sometimes you have to look at it and you have to understand and figure out what the problem is. And that's the same thing as writing code, and that's the same skill as writing code. And so what I wanted to try to say is practice writing code, but also look for other ways to learn how to troubleshoot and build things and troubleshoot things and solve problems. And that is my last slide. And I'll come back and say, I'll stop sharing and say, anybody have any questions about that? Is that a question in the back, or are you rubbing your head? Yep, the girl in the green shirt. Wait a minute, hold on, time out. Come closer so I can hear you, because it just sounds like glug, glug, glug.
Come up to the left, to the left.
Right here. So when you showed
Hold on. Wait, come close.
I can't see you. Okay.
Yep, I can. That's okay. I can hear you. That's fine. Hi.
When you showed all the different code programs,
Yep.
My brother codes with JavaScript a lot.
Yep.
He's making his own video game thing. Some of those. He has some of those.
He
Yeah.
uses languages.
Yeah, he uses the apps you showed.
Yes. So those are very common, and they're also free to a lot. A lot of people can get them for free. And so yes. Now, did you ever look at him write JavaScript and see how he writes it?
I've tried, but I kind of stink at it.
It kind of almost looks like English, except that it doesn't have all of the words. It just has a few words. And if you read it, sometimes you can kind of understand what it's doing. But and the other thing about writing something in code like that is he probably has to write a little bit and then test it and make sure it works, and then he writes a little bit more and he tests it and makes sure it works, and he keeps building on top of it that way. Good. Well, thank you, and I'm glad you recognize one. So I see somebody. Let's see. I see somebody's right in front.
All right. Go ahead, Jackson.
Mr. Blue.
Oh, yeah. I have. So can Geno cure every kind of cancer?
Not yet, but here's what's happening is they'll test a whole bunch of people who are sick, and they'll look for things that are the same. And if they can find things that are the same, then they know that those people have a similar kind of cancer. And then if the medicine works on one of them, it usually works on the other ones too. And so they by looking at the genome, they can narrow it down and find people who share a common problem with the gene, and then the same medicine will help them.
And can you decode every person's DNA, like a blood sample?
Yes, every single person has a gene, as well as every single animal. And so you can take a blood sample, or a hair sample or a spit sample, or you could scrape some skin and test all of those things and get their genome off of all those things. In fact, if you, there are some places where you can spit and send it off and they will send you back your genome, and it will tell you like, oh, you're Irish, or maybe you're part Irish and part Chinese, or whatever you are, they can tell by looking at your genome.
And this is the last one. To decode DNA, do you have to know how to code real life machines and like software?
So you have to know how to decode. So you teach your software how to look at those genes. Now, remember when I told you there's 3 billion letters in a gene? Yes. There's 3 billion letters, but they're all the same one. The scientists call it T and C and G and A. So it's TCGA blended 3 billion different ways. And so the scientists have to be able to read that very clearly and then save it as a record so that they can go back and look at it again. And then they'll see what's the same about different people or different diseases.
Okay, thank you.
You're welcome.
Any other questions? Because we're just about out of time, unfortunately. Anybody else? Coding questions? Well, this has been awesome. Thank you so much.
Thank you.
You're welcome.
Next week we're doing Hour of Code. We've done it for the past 4 years, and we always use code.org, and they put out like a new feature every year. This year it's a new version of Minecraft where you have to actually decode, like you have to go in and figure out what the problem is and like help the agent solve it. So so that's gonna be a lot of fun next week.
Excellent. Well, have fun, you guys.
Well, what do we say to Uncle Miller?
Thank you, Mr. Miller.
You're welcome.
Thanks. Talk to you later.
Bye.
Bye.